Thank you everyone for joining NTech for implementing a GIS program within the modern campus. My name is Michael Brennan. I'm with NTech and Business Development, and I will be the moderator. If you have questions, certainly you can ask them at any time. If it's applicable to the current slide or what the presenters are talking about, I'll interject to ask the question then. But if not, we'll get to it at the end of the presentation. We're hoping that this will be about 45-minute presentation, and then we'll leave some time for Q&A. So today we have two speakers. We have Leo Scott, who's a planner and GIS specialist, and Katie O'Regan, who's our facilities project manager, who has worked on a number of these GIS projects. So we'll turn it over to them.
All right, thanks, Michael. So today, just to give a quick run through, we'll cover a brief overview of what GIS is. We'll cover some core GIS concepts, and then we'll go through 3, maybe 4 if we have time, case studies that employ those concepts, those core concepts we'll talk about. And then we'll spend a little bit of time talking about other applications and taking questions. So we're talking about how changes to the modern campus impact how you might manage or you need to manage your facilities. Through about 2010, you're seeing a pretty steep increase in enrollment in campuses, which resulted in a lot of construction. And then about around 2010, you started to see a decrease in enrollment, but also shifting student populations, more remote learning, changes in pedagogy, requiring more intensive technologies, which then put demands for more electrical service, IT, data on your facility. So even though you might not be building new facilities on your campus, there's still a lot of construction and a lot of changes going on with your facilities and the utility systems. So these can present challenges to facility managers, generally more at the building and then facility level, but also directors of planning, and then facilities and operations. Some of those challenges as you modify your utility systems, add more features, upgrade your mechanical systems, is just keeping track of your assets. What do you have? Where are your major pieces of equipment? Where are your underground utilities? Another challenge is also centralizing institutional knowledge as things change rapidly. You may have somebody on your staff who just knows everything about the campus, which is great, but how do you perpetuate that knowledge into the future? And then one of the other challenges is finding value in and making the case to invest in some of these technologies like GIS.
So thank you very much for coming to the presentation. So just wanted to talk to you a little bit about what GIS is and give you a baseline understanding. So GIS, the definition of it is going to be a software framework that captures, manages, and analyzes data or information in a spatial manner. And what do we mean when we're talking about spatial manner? So unlike other mapping types of software like CAD, GIS is going to look at data on a virtual globe on the surface of the earth. So it places your information on top of that globe. And GIS is utilized to query or to ask questions of that information by layering it and filtering that information to get out the nuggets that you need to solve those problems that you have. If we look at GIS is everywhere. I mean, you get in your car and you get ready to go to work, and your phone tells you, well, there's this route to go to work and there's this route. It's using GIS in the cloud software framework to give you a best solution. We're all familiar with Google Earth, aerial photography, and drone imagery. Software packages like Waze, which everybody uses to add information to the GIS in the cloud. And there's many public and private resources that provide mapping that we look at every day that's all based on GIS. Today, we're going to focus a little bit on a company called Esri, the Environmental Systems Resource Institute, Research Institute. And that software company is pretty much the professional main source for GIS computing in the United States and around the world. So a couple core concepts of GIS and why it works so well for campus and facilities management. We talked about real-world location information. We're identifying information on a globe on your campus or in a city. It centralizes many different data types. So not only is it a map, but it also contains tabular, database information. It can take in and utilize video and photo information, drone photography and drone information, and survey data. GIS analyzes this information by, like I said, querying and associating information that's close to one another and using geometry to study these relationships. And once that analysis is done that is needed, it can play well with other software packages like Excel and Word, and Google Earth communicates with Esri, and then that provides a facility manager the tools it needs to communicate to their staff, to boards and commissions, or to the general public. The GIS is scalable, which it's utilized on any type of machine. So it can be used on a laptop computer, through a server, and through phones and iPads and other devices.
Mm-hmm. So Leo kind of talked about how GIS can do all the things, and that may seem a little overwhelming if you don't have a good idea of how you want to use it on your campus yet, or how to scope that project. So we want to go over some considerations as you begin to develop a potential GIS for your campus. The first thing I want to hit upon is its purpose and then potential users. As you begin to scope a GIS development project, think about not just the data that you think you want to collect, but how the output or interpretation and analysis of that data is going to later help you make decisions. And then also think about who the end users are. You may, within your facility staff, just, a couple of you use the GIS program and the raw data, and maybe you're just in the raw data all the time and you're not really looking to output or filter specific maps to, the public or the board or end users who are only interested in specific information. So there's a breadth of purpose and users there that you want to consider. The next thing you want to think about is your current media. And when I say media, I mean, do you have campus maps in CAD? What are the file types? Do you have campus information in PDFs, or do you just have paper copies, hard copies in your office? So we can use all of those to set up GIS for you, but you're going to have to consider the amount of time and effort it'll take to collect some of that information. CAD is generally easier to import and start with, but if you have paper information, that doesn't mean that's a barrier to getting going with GIS. You also want to consider the nature of your assets. Are you concerned about locating underground utilities? What level of accuracy, as Leo will touch upon? Are you interested in just surface points, or do you really want to track some detailed information inside your buildings? Depending on what you want to track, it will affect how you develop your scope and then how you survey and collect that information.
So we'll talk about the level of accuracy, and we're mainly talking about how precise do you want your information to be in the field. So in some circumstances where you have valves that need a lot of precision, like almost survey grade to centimeter precision, to other items that may not require such accuracy. The level of accuracy that you are seeking for specific items can dictate the scope and even the type of data collection that you would require, whether it's a GPS or actually having a surveyor go out in the field. Technical and logistic limitations also come into play when you're planning to do your GIS. Mainly when we're talking about GPS data collection, the position of the points that you are looking to collect that are close to buildings, that are under tree cover, or impacted by winter conditions can impact the success of collecting high precision data. So before we go in the field, we would want to look at where these points are and if using a GPS is the correct way to actually gather this information.
Mm-hmm.
And then finally, maintenance. So you've built a GIS, you've spent your money and you've got this system. You want to make sure you keep it maintained. And the way to consider that is, do you need an annual maintenance program? Will you be looking at having your staff maintain it, or would a consultant be maintaining it for you? Those types of decisions would determine the type of final product that you want. Do you need mobile applications? Is it something where you're just looking at a Google Earth map, or you don't need something as robust? So those kind of decisions are important to think about before you start building.
Mm-hmm. And Leo, to hit upon accuracy again, what we often find is that some owners are gung-ho and they want to spend the time and the money up front to collect as much information as they can, construction level, construction grade accuracy, which is within a couple centimeters, but that's not always the best use of your time and money up front. A lot of surface features can be visually verified. So if you can collect GPS points within a couple feet, that's still going to be more than good enough for you to keep track of some of that information. So there's that consideration. More is not necessarily always better here.
Correct. It really depends. It really depends on what you're looking to do in the end. If you're looking for a surface feature that you can find within a few feet, yes, you might not need survey grade accuracy.
Yeah, thanks Leo and Katie for that overview and discussion regarding GIS. We have a couple poll questions that we're going to be asking the audience to fill out. So I'd like to do the first one now. I'm gonna launch the poll, and please vote. I thought this was a good start just to understand the audience. How would you best describe your familiarity with GIS? And we'll give it about 30 seconds, just to compile, some of these votes, to, get an understanding of, various levels of understanding of GIS.
Curious if there are any GIS rock stars listening in.
Well, Leo is a GIS rock star.
Yeah, but
but
I don't want to see
He's
it.
not voting.
I know.
That's not
And
fair.
I can't vote either for him either. But we'll give it 5 more seconds as they're coming in. All right. So I will share the results here. So actually it looks like 60% have some exposure and 40% says this is their first step in learning GIS. So
Okay,
this webinar
good.
should definitely be useful then.
Yeah, so we don't want to, harp too much on some of the really basic information, but if, like Michael said earlier, there's a question box down at the bottom. If we seem to have glossed over something, please send in a question. We can go back and visit that in more detail. Okay, and the one point I really want to dig into is this concept of the user groups, the amount of data, and the end users. So I think of the GIS really as this pyramid where the foundation is a ton of comprehensive raw data. So it's a lot of, data points, it's lines, it's coordinates for all those, the location information. There's a lot of raw information. And then thinking about who might be using that or be interacting with that is usually going to be more boots on the ground. So it could be facilities manager, a building manager, a facilities director. So those people may be involved in collaborating with the consultant, figuring out what data to collect, how to collect it, the characteristics and features of each data point that they want to record, which could be things like not just where the pipe is, but what's its diameter, what's its material. So at the base of this is a lot of raw data. Above that, we have potential department heads, directors of planning, people who maybe are not as involved in the day-to-day or month-to-month maintenance of the GIS information, but are interested in its output. They are interested in the analysis it can provide to help them make decisions. As we move up in the user groups, we have groups that are touching less of the data or are only focused on some specific outputs. So you could have work teams or project teams They could be within your own organization who, like facilities maintenance guys who are using the GIS output to locate specific information and perform maintenance or O&M on your campus. They may be using an app, they may be using a specific set of maps that are output from the GIS, but either way, they're dealing with a reduced amount of data that's been filtered for their purpose. And then at the top, we have considerations for committees, board members who may be looking for a very specific conclusion or piece of information analysis to help them make more strategic decisions. This is where the GIS is really powerful, that it can analyze and boil down the information that you put into it into a handful of very powerful visuals. And lastly, may not be applicable to all of your campuses and users, but we can have students or the public simply reference things like maps for wayfinding. Maybe they want to find accessible entrances on campus. They're only exposed and consuming a very limited amount of the data that's in the GIS, and it's really just for reference only. So now we'll cover some real-world applications. We have 4 case studies that are going to emphasize some of the considerations that we just talked about. So the first 2 we're calling asset inventories. We have a basic asset inventory and an advanced one. Interior space mapping, where we actually used the GIS and being able to draw shape files to represent rooms on floor plans within buildings. We'll cover how we've used GIS for more strategic planning decisions, and then we'll spend a little bit of time talking about other potential utilizations for campus. So our first application is a basic asset inventory. This, as we go through, this will set up the basic methodology of collecting site information, whether it's through CAD or PDF files, basically through a desktop analysis. So we're collecting information first before we go in the field. And then this linear process involves entering that information into the GIS, outputting some basic field maps, verifying information in the field, and then outputting final deliverables for the owner.
So the first step, and this is a similar first step for almost all of these applications, we had received, I guess there were 3 or 4 CAD files for the campus itself. And these CAD files were mainly drawn in paper space, so we're talking about XY coordinates on a page and not on the earth. So one consideration is we create the space map by aligning it with items we can find in the surface of the earth. Once that information has been aligned, the CAD data itself is theoretically copied and pasted into the GIS framework to create our base map. The next step of this process is to actually receive additional information about utility systems surrounding the campus, or penetrating into the campus. On the left here, we see CAD or GIS data that we received from a gas utility, which we were able to integrate that directly into the GIS without much manipulation. We didn't have to do a lot of work extra to get that into the GIS. While on the right side, we received PDF and paper files from a water and wastewater utility that we had to literally bring into the GIS. We brought the image in, aligned it, and then we had to trace over those lines of the pipelines and draw in the manholes and the valves, and then manually type in the data associated with those features. So you can see different levels of complexity with each one of these data systems that we're putting in. From here, we generated a GIS base map that was utilized to go into the field. Our field crews took that base map and used that as a guide as they walked through campus and located the valves and the manholes and other features that they were looking for. They used a professional grade GPS unit that got them down to centimeters of accuracy. And with specific or certain items like manholes and inlet boxes, they filled out paper forms that provided information about the diameter or the dimensions of the items they found, and then also brief sketches to record the location and the flow of water. And then finally, with every location they found, they took photo evidence of the items, either opening up a manhole or just simply taking a picture of a fire hydrant or a meter on a building.
So Leo, this is a good example of simply getting your GPSing some points in the field. So we're not talking about underground utilities, just the points like the manholes, the valves.
Correct.
And using the GIS's kind of ability to store documentation to fill in all the details with some of these paper records. And then once that's entered, the details of the manhole are always associated with that manhole point in space. So you don't have to go back and re-verify.
Correct. All that data that was on that sheet was included in the GPS when they recorded it. So they filled that out as they were filling out the sheet in the field. The sheet in the field was a physical record of the recording. And in some circumstances, it was a physical inspection of the condition of, say, the sanitary manholes. So all that data was gathered into the GIS, so imported into the GIS, and that GPS data was utilized to correct the position of manholes and lines. So once we got that into the system, we exported it as a Google Earth friendly file. It's called a KML or a KMZ file, which we then were able to email to the client. The client can double click that and open it in Google Earth with no trouble and view the information that we have. So we just have manholes and lines that are color coded based off of status or ownership. And then if we move to the next slide, we see what it looks like when we zoom in and focus on one. So you would be able to click one of these manholes, and then this table that pops up is all the information that was collected in the field onto the GPS and also collected on that inspection sheet. Also at the top of this pop-up that you see here, you see the purple hyperlinked files. Those are the photographs and a digital copy of the inspection sheet. This is all attached to the Google Earth file and is included in the GIS. So it's not kept in a separate folder somewhere. It's all in one place and accessible through the GIS.
So Leo, with the KML, the Google Earth file, this is a really good option for an owner who might be on the fence about actually investing in ArcGIS subscription, because they don't actually need to have an AGOL, that's ArcGIS Online, AGOL account to get this information. They can just download the KML file or upload it into Google Earth and see all their information there without setting up any sort of account.
Correct. It's a great snapshot tool, and in some circumstances you can use it as your main file. The only issue is with the Google Earth, it is not as easily updatable in the future. So if you wanted to go out and change something in the field, it's a little bit harder to update a KML file than it is an ArcGIS file. So if you're looking at a snapshot and you just want to utilize that as a reference tool, it's a great thing to have. But if you want something more robust, you would probably want to consider a different option. And this slide here indicates the second type of output. Now, in this circumstance, we output the GIS data as PDF maps and paper maps. And also, we had a CAD series that followed along with this that the client could use for passing on to other designers or engineers when new projects would occur.
All right, great. Thanks, Leo and Katie, for that overview of the first case study. We're going to do another polling question now, and I will launch it. We'll give about 30 seconds or so for people to answer it. But what is your primary resource for utility and facilities reference? So I know some clients that I've worked with, I've seen, a lot of them have CAD files, but I also know that, paper files certainly exist from a long time ago. I mean, Leah or Katie, what have you seen?
We usually see a good mix of CAD files. Usually there's some attempt at a master file, but it's really hard to keep track of who last edited it and what the actual current version is, especially when you have multiple stakeholders involved who are changing the data. And then there's always some paper thrown in there of, oh, but we redlined this and we didn't get to update it yet. And that was a couple years ago. And it's just, the data management is really tough.
Yeah. Yep. Everyone's looking to manage their data better. All right. We're going to end this poll. Share the results with everyone. So it looks like 50% use facility staff and 25 paper plans and 25 is CAD. So I would say that's pretty much what we've been seeing.
Yeah, and that the facility staff that knows everything is so valuable, and you want to capture that information before they leave.
Yeah, and that's, you know, I know that happened with a recent project where, you know, the client basically said, I have some people that have been here for 30 years that are about to retire, and I want to make sure that I get that information, you know, recorded and used for, you know, future. So that is definitely important. All right, I'll get back to the next slide here.
So our next case study, we're calling a more advanced asset inventory. Compared to the first case study, this was a much more collaborative and iterative process with the owner. So we still did start with the same approach to the methodology, which was collecting campus information through CAD, PDF maps, site plans, before we even went in the field. But in this case, the owner had a lot of conflicting information. They had information from a lot of different sources, including other consultants who had done construction grade surveys for construction projects on campus. And they wanted to preserve some of that lineage. So they didn't want to just have a final output, which was a snapshot of what they had at the current moment. They wanted to preserve a lot of the historical information that, that was in the older CAD files, so that they could go back and actually track some of the work done, the decisions made, and be able to verify when lines were either abandoned in place, they were obsolete, or they were removed.
So similar to the previous project, we started with a master CAD file. This CAD file utilized an aerial survey of the buildings and the topography. So we had a little bit more of a precise base map to work on. But as you can see, the various line work that's been done for all different types of utilities, all color coded, and also include diameter and some other details in the CAD. A lot of these lines were brought in from either as-built drawings or manually drawn in. And this is where the question of lineage and accuracy and precision in the drawings came about. We were tasked with bringing this information into GIS. Once again, it's a simple copy and paste process bringing this stuff in, but you have to sort it out to determine which layer that you're going to be populating. So we had to do that and build our base map, and then, you know, start the field work.
So Leo, in the process of importing a plan like that, where they already had some layers defined, I'm assuming the colors are by layer, you know, like the blue is water line, green might be gas, or yellow is gas. So when you brought that into the GIS, it preserved some of those layers, so you were able to then kind of reassign those lines to the specific database fields that were in the GIS.
Correct. Some of them, like the water lines, we'd have things like chilled water or heated water or just potable. We had to delineate through looking at the CAD file itself, because some of those labels and layer names were not, you know, straightforward. But we would look at those, ferret that information out, and then drop the water lines in the portion of the GIS that covered water. Same thing with all the different utilities. But that is sometimes a process where you're going through and determining information. Second, sources of information, and we got quite a few different sources. These are just a couple of examples. So on the left, we have a PDF or paper output of that same CAD file, in which the facilities manager kept a red line record of new materials, new lines, new valves that may not have been provided in GIS information. This is the institutional knowledge that we're talking about. He also made little circles and blobs around areas that he knew there was a pipe there, but they didn't have any concrete drawing data. So at those points, we had to make a decision. Are we going to go out in the field and update this or look for more drawings? The central image here reflects a book of lighting diagrams that the college had, and also had lighting IDs, which we had to go out into the field and verify those ID numbers that may have been tagged on the lights. So this was another resource that's not CAD or other source. This is out of someone's head, that we have to grab. And then finally, there was a utility, it was a telecommunications survey of the manholes. And this information that you see here is ducts and interduct information inside a manhole diagram that we had to record and implement in the GIS as well. So all that information was placed in the GIS. Same process in the field where we created field maps. Our field folks went out there, GPS the locations they could find, and then simultaneously we created a web mapping application using the Esri software that would allow the user to log on, look at the line work that was being done, and then to also see the lineage of the data by the highlighted colors. That tells us where the data came from. And then the hash marked information, that indicates where a line was either abandoned due to construction, or we just couldn't find it in the field and needed verification. So this was a communication tool that the client was able to log in, mark up, and we can make further decisions about gathering information in the field or to find more information in drawings. So this is part of that collaborative data update.
So Leo, this was an interim step in the process, correct?
Correct.
Like
this is
the final deliverable wasn't this mess of lines.
Correct.
Mm-hmm.
This is a working web map that's used to communicate between us and the client. And then this would be the final deliverable. So this item shows, and it's similar to the Google Earth image we showed back in the past, where the final lines are displayed. This is all the utilities at one time. But the difference between this and the Google Earth is you're able to click a point and then actually edit it. So this can be taken into the field using a mobile device by their staff after all the work has been done, and update information, add points and lines. So it's a much more effective tool for moving forward once your GIS is built.
So the geodatabase, that's basically the core of the GIS, is set up so that you can fill in and adjust and edit some feature information after the fact. So in this example, we didn't have all of, let's say, the pipe material or diameter information when we were in the field. So we set up a standard form, a standard list of fields for each utility that we could populate later, or that we could correct later. And then we even had fields that identified which lines and points needed a closer look later and which ones were finalized.
Correct. Yeah, we kept for every feature, and there were hundreds of different types of features in this database. We kept a completed status and a pickup status, so we could track that information to find out what was done and what was not, and then even a solutions type of field to identify what we had to do.
So this is very much a living document.
Correct. It's ongoing. You wouldn't consider this ever complete.
Hey, Leo, question. Someone asked, in either the first case study or this current one, were any of the depths recorded in terms of any of the utilities that were underground? Steam line, was it 3 feet underground at this point or that point?
Correct. So in this project itself, what had happened was the school had gone out at certain points and times, and you can even see those light colored X's going down the center. Those are field recordings that the school had taken of depths of line. So at those points, we would identify the line ending and the line beginning depth. So therefore, you know, especially at points where you're entering a building or you're entering a manhole, and then also with all the manholes that were opened, we confirmed the depths and inverts of the pipes going in there. So there is a lot of depth information that's gathered.
And how about the first case study? Was there any depths recorded there, or was that purely imagery,
No.
Google Earth looking at?
Correct. It was more of a 2D type of thing where the client just wanted to know where the line was. And that's kind of important, because if you think about it, you know, getting the depths when you're planning construction projects is very important. But I think the client in the first exercise understood that, okay, even though they're going to be doing construction work, they will be gathering the depth information for that specific area at that time. And they never really had the quantity of staff to go out there and measure depths for us to record. So they're doing it ad hoc.
Okay, thank you.
So we're going to shift focus here a little bit, and our third case study is actually looking at using the GIS for interior space management. We've covered mostly utilities, exterior grounds features in the previous two, but GIS also gives you the tools and the ability to track volumes as rooms inside. So this owner was interested in being able to track different, I guess, ownerships or involvement with all the different spaces in their buildings across campus. So classroom buildings, they had faculty residences. They wanted to track departments, who was responsible for O&M, being able to share information about rooms and buildings at certain points in time with their campus safety. So methodology was similar. We collected a lot of desktop information, but this time we were looking at building plans before we even added a lot of spatial detail to the GIS.
So in this instance, we had created a web mapping application using an Esri-based template. And in order to utilize that template, we had to properly scale and align all the floor plan drawings on campus. And then once those drawings were aligned and scaled properly, we stacked that data on top of each other. So what we're looking at here is a 5-6 story building. So each floor plan, set of floor plan data was aligned on top of the other, you know, the previous one in the proper place. All of that data was imported into the GIS, and we utilized this web application because it allowed us to toggle between floors. Another interesting thing about this application is the client was seeking a way to search out names of individuals or specific room numbers, which we had to do a little bit of modification to the actual web application software itself to allow that to happen smoothly. So this is a very customized application.
And Leo,
Yeah, so Leo, just go ahead.
I was just going to say there was a question about the background, why the background looks different in this one than in the previous.
Correct. So this was part of a drawing that was added in on top of, it was part of a, let's say, a landscape area drawing showing the grass and the sidewalks. In the web application, you are able to toggle between different base maps. So we have this CAD drawn base map, but underneath this, you turn it off and you get your aerial photography and other base map sources that are provided through Esri's server. So they're piped directly into the application. And you do USGS maps. There's a world street map that's really has fantastic information, but that's the base map, and that's why this one looks different.
So it is easy to change or decide, you know, which type of base map visual you want, correct?
Correct. In this web app, it's a flick of the switch. Literally, you turn one on, turn one off. It's simply another layer to look at. So the next portion of this application, so it functions similarly where you click a space and you get some information. The interesting part about doing this is the owner had their field staff go out and populate the space information, the type of space, what department, and they did it through the use of the web application itself. Something interesting to consider about this is a single web application, but there are several different types of departments that use it. So the public safety, the registrar, even the local police department utilizes this application because it has very important information if they have to respond to something in a building. We don't need or want folks viewing that to be able, these departments to actually edit the information. So based on their login and how their login is set up, this application kind of shuts down editing capabilities. So it's very smart that way, where we can access and modify user capabilities in editing and locating information. And then finally, for the facilities manager, they were interested in accessing the information within the 8,000 spaces that we mapped. They wanted to be able to filter out based off of department type, department name, space type. And this function of the application allows us to export out specific rooms based off of a query, a search for information. This data here, this table that you see, can be directly output to Excel and displayed for presentation to, in this case, it was the space planning commission for the school itself. So they were using this to generate reports for the space plan.
And this is where the capabilities of the GIS far outpace what you could do, say, in AutoCAD with keeping track of your interior spaces. As you can see from the table, we have assigned so many different layers of characteristics to each space. You've got whether that space is publicly accessible or not, what type of space it is, information like ceiling height, so we've got some XYZ information in there, the name of the space, the department that owns it, the department that occupies it, because they could be different. There are so many layers of information that are embedded in each room that it'd be very difficult to sort and filter and export any of that information in CAD. So the ability of the geodatabase to hold all of this and then filter it through certain queries is really powerful.
Yeah. Thank you very much for that. We're going to get into our final polling question. I'm going to launch the poll now, give about 30 seconds. This is multiple choice, so click more than one if you wish to, but what of the following would you find GIS an effective tool to help with? So, in the previous examples, this previous one here, talking about interiors, the other ones we're talking about utilities, but I know there's been discussion with arboretums, wayfinding as well. So I'm just curious on the answers from the attendees today. So we'll give it another 5 seconds. See, most votes are coming in. All right, so I'll share the results. So wow, okay, 80% looking at wayfinding, 20% for the arboretum, 20% for public safety, 20% for COVID-19, 40% for utilities, and 60% for space planning. So it covers a lot of different things.
Yeah, it seems like people are thinking creatively, and that's good.
Yeah, absolutely. All right, we'll get to the next slide here. Thank you.
I'll just go quickly through this one. This is the last function of this. We built a series of drawings. We received a series of drawings for this, and the need for the drawings to be updated and archived is very great. But the size of the files prevented us from efficiently exporting these into the handheld application. So how we worked it out was we store these drawings on a secure server and then pipe them into the application. So what we effectively had is a living archive of all the drawings that's accessible through the web app. And what we do is we mark up the drawings where we have a change, and then when we receive a new as-built, that takes its place, and then that drawing gets superseded and put in a different archive, all accessible by the application.
Okay, and our last case study builds upon the interior space inventory that we just talked about. In this circumstance, the owner wanted to get more detailed spatial information so they could make strategic decisions about whether to decommission buildings, lease new space, so they had a mix of owned and leased buildings, and then also be able to give guidance for future space, renovations and space planning and development based on space use standards unique to their organization. So similar to the last case study, we did begin by collecting floor plan information, building that out in the GIS so that we could represent each building floor. The second step was then first of all, identifying each space type and then analyzing how it compared to BOMA space classifications. So this owner wanted to really understand how much space they could really use for their staff. They had a lot of administrative staff. They wanted to know, well, how much true, rentable office space do I have, or net assignable space do I have? So we identified spaces by those BOMA characteristics, or those space definitions. And then our next step was to work with the owner to develop space use standards in terms of how much square footage should be allotted to each staff type. So what is the range of an office size for a director versus a project manager? And also, how much additional circulation space would you expect for an office of a certain size, number and size of conference rooms and storage? So we developed those standards and we entered those tables into the GIS and then ran a series of comparisons, so formulas, that would identify whether each room fell within the standard or deviated from the standard by 10%, either under or over. And so those are the red, blue, green visuals that you see on the right side, which created a really quick way to visualize what were the problem areas, what were areas that fell within the standard, and where did they have extra space. And in this scenario, the final conclusion was that across all the buildings that the owner had in their portfolio, they did not have enough space to meet their own space use standards.
All right, thank you very much, Katie and Leo. We're at 12:52, so finished right on time. There were some questions that came in that I wanted to ask of you two. So we'll start with about drones. If I have updated aerial imagery from a drone, can they use that for a base map?
That can be integrated into the GIS. And I think we do have experience migrating that in, utilizing our own drones for the water and wastewater department. So yeah, it is definitely something that we can integrate.
Great.
Well, and so to be clear, the drone can pick up survey grade information that we can import, or it could just pick up aerial photography. So not all aerial photography has been rectified, meaning it's not aligned with the real world coordinates, but you could still use aerial photography as a base map. It just wouldn't be quite as accurate.
Correct.
All right, great, thank you. Another question. Could I tie other building information such as deferred maintenance to a GIS?
Absolutely. And actually that last case study was part of a broader facility condition assessment where we used the resulting condition information and some of those estimated construction costs to remediate deferred maintenance to inform some of the final decisions about whether they would sell or decommission a building or renovate. So what you didn't see in this series of images was additional analysis that was color coded by which space was in good condition, fair condition, or poor condition. So absolutely, you could include that information. So it would be similar to the way we had uploaded some like utility detail information. So it would mostly be additional fields that are tagged to each space, but you could then query by what spaces are in bad condition, or if it was utilities, you know, which utilities and which surface features are in poor condition, and filter out that information.
Great. I have a couple more questions here I want to try to get through. Could you start with Google Earth and efficiently scale up to something more advanced if adoption and functionality changes?
Yes, you can. So like we said, the GIS Esri software does play well with KML files that come from Google Earth. And if you were to start with the Google Earth project, you would be able to import that into an Esri Geo database and continue on mapping that direction. So the answer to that question is yes.
Right. So even the projects where the final deliverable was the KML file, so you could just view it in Google Earth, there is still a Geo database behind that
Correct.
that we use to populate and analyze and output that KML file. So you would then kind of ignore the KML file, go back to the GIS that you originally set up, which was until now in the background, and then continue building and populating that.
Great, thank you very much for that. We have two more questions. What's something you've seen put into GIS that you wouldn't recommend or that didn't turn out well?
I would say maybe not that it didn't turn out well, but we have seen instances where an RFP or a project that was already scoped called for like construction grade survey accuracy of within a centimeter or two, and it really just wasn't necessary at that point in the project. And so it ended up being additional labor, additional time in the field, and thus additional cost to do those surveys. And then the owner didn't really utilize that data immediately. And then by the time they were ready to use it, it was a couple years down the road, and you needed to do another survey anyway for some of those areas. So I guess that's, I guess it wasn't quite scoped or planned right, and there was a little bit of duplication of effort that we could have avoided.
Okay, thank you. One last question here. My master research is about using augmented reality for wayfinding in the university campuses. Is it easy to consider GIS as a base to integrate it with immersive technology tools?
That's a really good question. That's a little outside the purview of what we've done. However, I have seen some of like either 3D tours or virtual reality. I've seen some architects use the GIS information to go from point to point through a model that was already developed, so BIM model, that had those coordinates embedded in the BIM information. So probably not the best one to speak to that. I have seen it done, and I think it definitely could be a good consideration. Whether it's easy, I'm not so sure because I haven't worked through it.
Yeah, same here too. That would be a real cool project to get involved in, I gotta say. But yeah. GIS, if you're utilizing GIS as a indexing device or map location device, I've seen that as well, where you have virtual reality tours integrated into an online GIS. The GIS in that circumstance was probably just used as a reference tool to identify those points of interest where you would link into BIM or something like that.
Right.
I definitely think there is some sort of connection. I would check the Esri website out and see what they offer in that area. So yeah.
The last time I used anything like that was in college. So it was a while ago as part of my pre-thesis. And I think we did something like what you're talking about, where we did use coordinate points to basically identify like a 3D view down a path. So that could potentially work.
Great. All right. Well, it's almost 2 minutes of 1 o'clock. We did have one question that popped in here, so this will be the last one we'll answer. Someone asked, that they have updated CAD plans for the utility systems. Why would they want to use GIS?
That's a good question. I guess the benefit of the GIS is that its structure of being a really large geodatabase with an ability to standardize your information allows you to hold a lot of data, but then also analyze and update. So it's really the benefit of not having to go back and cross-reference or cross-check, as well as being able to add information that CAD may not store very well. You know, if you want to add photos, you want to add manhole reports, and then build upon it. So CAD certainly is a really good option for a lot of more, you know, two-dimensional or simpler applications. But if you're starting to think about managing related data, you know, where does it touch your buildings? What is the depth at which, you know, the line goes in? How can you visualize that? GIS really is a great option to manage a huge amount of data.
Correct. Yeah. GIS also integrates things like SCADA and other data collecting information that's live. So if you have an online web mapping resource, that's not necessarily something that CAD was designed to do, is to gather that information from outside and use your map as a living tool. So it's great for design. It definitely is great for design. And if you're managing CAD or BIM files, that's one thing. But utilizing it as a deeper knowledge tool, I think GIS is a much better choice.
Great. Well, I appreciate everyone's time. We have Leo and Katie's information up on the slash screen. You know, if you want to reach out to them, if you have any follow-up questions, certainly do so. But appreciate everyone's time and joining us today. Thank you, Leo. Thank you, Katie, as well, for that informative presentation on GIS.
All right, thank you guys
very
for
much.
attending.
Have a great one.
All right, thank you.